Welcome to the last non-lightning talk slot of the afternoon. I have to say, I am really amazed that there's so many people in the room here for my talk, given that I'm performing opposite Ryan and Fox Dots. But I checked with Ryan, and hopefully we will get to see him perform at the after party this evening, so you won't be missing out. So before I get started, I would like to give a huge thank you to Igor in the front room, who just helped me out because my computer's not working. I am Rae Knowler. I'm a software developer, mostly back-end web stuff, from Zurich in Switzerland. You know what I look like, so here's a picture of my town looking far more green than it really is. I do a lot of Python. At the moment, that's mostly at home, but also some for money. And apart from that, I mostly do PHP and some Go and JavaScript. And I work for Leap, which is an agency in Zurich, who have supported me in getting here, so thank you a lot to them as well. Let's dive in. What is property-based testing? It's something of a buzzword at the moment. You have probably heard it. You probably are wondering, what is the property? What are we testing? Well, in short, property-based testing is a kind of software testing that goes like this. You define properties about your code that you expect to always be true. Rather than defining specific scenarios, like examples where you expect things to happen. If I call this function, I expect the answer to be 12. Instead, it's more like a mathematical equation. The result of this function is always equal to something. And when you run property-based tests, you give the test input, and you just check that for the input you give it, the properties you want to test hold. You can also, this isn't strictly part of property-based testing, but it's often done. You can also automatically generate random inputs for your tests. And this is what we're going to be looking at for the rest of this talk. Just to give you an example, because probably it's more clear if you see it on the screen rather than what I just said. In sort of normal example-based testing, you might have defined a sorting algorithm, MySort, and you say, if I give it this particular array of integers, then I expect the answer to be this. I give it 3, 1, 2, I want 1, 2, 3 back. And in property-based testing, you would rather assert, so my sort of any list should always be equal to the sorted list, just as Python defines it. And that's a property. So what is hypothesis? If you have looked at the schedule for this talk, you will already know the answer to this. Hypothesis is a property-based testing library for Python. It's inspired by QuickCheck, which is the sort of iconic property-based testing library, which was first created for the Haskell language in, I think, the 90s, so it's about 20 years old now. It has a website, hypothesis.works, with lots of information, lots of articles. It's all really readable, and it has good documentation as well. So really, all I want to do with this talk is whet your appetite, kind of get the basic concepts in your mind, and then if you want to use Hypothesis, I would really recommend just installing it and having a look at the articles and docs, because it's very clearly explained there. This is David McKeever. He's my ex-housemate. We're still friends. He just moved to a different country. And this is Sinister Katzer. He is one of my current housemates. David McKeever is the creator and lead developer of the Hypothesis project. And Sinister is, in some ways, the inspiration for Hypothesis. And this is because he's very fuzzy, and he likes eating bugs. So, yeah, to go through, again, what makes Hypothesis special. As I said, it generates randomized test inputs, and this is called fuzzing. That's why the joke about the cat. And what this means is that when you write your tests, you no longer have to make and maintain a whole directory of fixtures for your tests. And you don't have to come up with examples and try to cover the whole possibility space for your functions, because Hypothesis is there to do all of that for you. You just say, Hypothesis, this function expects a list of integers, or whatever. And Hypothesis will come up with that for you. By default, it tests 100 examples until it finds a failing case, but you can adjust that. The really nice thing about Hypothesis, and part of what I think really does start to make it special, is that once it finds a failing case, it shrinks the examples it's found to find the simplest possible failing input. So you can really see, oh, this is what makes it fail. And also what's cool is that when it's done that, it remembers interesting inputs. So it has a database, which is actually a kind of directory structure that it just saves in the same folder where you're running the tests, which contains the details of tests that of inputs for your tests that have failed before. This is really nice because it protects you against regressions. If you have a particular case where your function would fail and you fix that, and then later on, it's a long-lived project, a year later you change some stuff, you know that if you have broken that same thing again, Hypothesis will still be testing for that, and it will find that for you again. So you don't have to worry on it coming up with the same randomized input, although that is also fairly reliable. The nice thing about saving this database of failing tests is also that you can commit it to your version control if you like. And furthermore, you can explicitly tell Hypothesis to test for specific inputs if there's something you really want to make sure doesn't fail in the same way again. Hypothesis can deal with complex data types. We're going to look at an example of that later on in the talk. And what's more, it's not a framework. I think this is really great. Hypothesis is a library, and that means that it just works with PyTest and unit test or nose or whatever test runner you want to use, and also other libraries you might be using. They can all just cooperate. Someone came up to me once when I was talking about this and said, so I make this library called Factory Boy, which just generates kind of random names and addresses and that kind of info for tests. Would Hypothesis work for that? And the answer is, yeah, of course it does. It's great. OK, so I have talked it up a bit. And we'll just start to demonstrate a really simple example. And here I also have to give thanks to my partner, David Stark, who is back home in Zurich. And when I called him up and said, my computer won't work, the entire thing is ruined, he very kindly downloaded my demo app and ran it for me and took screenshots. This was 2 days ago. This is the earliest I've ever had the demo effects kick in. It's probably a record. So we are looking at my sort, and I am possibly too lazy. I'm a very lazy programmer. This is too lazy. It's kind of fingers crossed. You give me an unsorted array, and my function will just return it to you and say, this is probably sorted. But we want to test this. And as I said earlier, this is test my sort. And the core of it is assert that my sort of an unsorted array is equal to the sorted array. The hypothesis-specific line in this example is the given decorator. And actually what I should have said is to install Hypothesis, you just do pip install Hypothesis. And then you import from Hypothesis in the imports line of your code, so as you would expect. The given is a function that takes strategies, so functions that will return a particular kind of data. And so lists here is a strategy function that's a built-in in Hypothesis, and so is integers. And all I'm saying here is, please give me lists of integers. So I run this, and it comes up with, 12, 42, minus 73, whatever, up to 100. And yeah, you can see I'm just running this here with PyTest, and the output is Falsifying example, an array with 1 and 0. Straight away, you see this is a very, very simple array because it's been shrunk by hypothesis. And it quite rightly says that if I pass in the array 1, 0 to my crappy sort function, this is not the same as the sorted array 0, 1. OK, so now you kind of get the idea of how simple it is to get started. So I'm going to show you something a bit more advanced. This is using a Django integration. So Hypothesis has extras, and there's an extra for Django, which I'll show you. I'm pretty sure you don't have to be able to code Django to understand these examples. Just a quick hands up. Anyone here familiar with Django? Yeah, about a third. So, OK, cool. So, in Django, it's just a basic model view controller web framework. And here's one of the models that I invented for my very small demo app. The app is supposed to be, it's a website that keeps track of all of the stocks you want to track on the stock market, and it gives you notifications however many times a day you want. Just, oh, this stock is worth so many dollars. This one is worth so other many dollars. And for this, I have a model of a stock subscription, which obviously has the symbol of the stock, so like Goog for Google, I guess, the value, and then when the customer was last notified, that's a date time, and how many notifications per day they want. And it also has here a method, next notification time. So if I know that this customer wants 5 notifications per day and they were last notified at 10 a.m., then when should I next notify them? And that's, you possibly can't all see that well. Basically, this function only just gets the last notified time of the customer, and then it divides 24 hours in a day by the number of notifications per day. And adds that date time delta onto the last notified time. Of course, I'm testing my app, so I write a test for it. And just to, maybe I have a lot of methods I need to test, I make a class test case for this model, stock subscription test case. You can only see one test here. Testing the next notification is after the last notification. And in the given, because I'm using the Django Hypothesis extra, Hypothesis knows all about my custom-defined models. And I can just tell it that this test expects a stock subscription model. And then obviously, in the test itself, I'm going to assert that the calculated next notification time is later than the last notification time. So I run this, and it's really exactly the same as before. Just run PyTest. PyTest collects all of my tests and runs them. And yep, it finds quite a simple error that some of you have probably already guessed. That when the number of notifications per day a customer wants is 0, we get division by 0, because we're just calculating the time delta by dividing 24 by 0. Yep, and it tells me I found a falsifying example, which is when I have a where can I see this? Yep, when the subscription is a stock subscription that says 0 per day. And yeah, this is a really simple error that hopefully you would either catch, or if you were coding late at night, one of your coworkers would catch it by code review. But it's also actually quite an expected case, right? You want to get rid of your subscription, so you dial it down to 0. You don't intend to crash the website you're using, and you shouldn't be able to. OK, I have one further example, which is a slightly more complicated one. And I just realized that I've been rocketing through my slides because I was a bit stressed about the computer situation and I'm talking too fast. So I'm just going to take a deep breath and calm down. Everything is fine. Okay. Yeah, right. I am going to get back on a normal speed of talking. Has everyone been understanding me while I've been... Okay. Thank you. You're a great audience. So, I have a final class example in my app. I'm getting a bit more complicated here. All of my customers have subscriptions, and they want a way to look at all of their subscriptions at the same time. So they need a portfolio. And so I define this portfolio model here. And it's also very simple. It has like a dunder strip method, which just says, I'm a portfolio of stock subscriptions. And it has an array of subscriptions. And the subscriptions have a median value. This is also a method on my model. Because I, as consumer who has like my portfolio and I want to know what am I worth, I want to be able to just see at a glance the median value of all of the stocks that I subscribe to on this website. And for some reason, I've decided to define my own median function because I'm a lazy but also a very clever programmer. You see, I can do this better. So the median value method on my portfolio model just returns what I calculate. So I get the value for all of the subscriptions, and I throw that to my median method function. And what that does is it checks the length of the array. It says if the length is 0, then I return 0. Because by this point, I have learned, and I'm checking for 0 input, because I want to avoid bugs. Then what it does, it's very simple. It just sorts the array of values. If the array is even, then it gets the two middle values and finds the average of them. Otherwise, if the length of the array is odd, then it just returns the central value. And yeah, when I'm getting those middle two, I find the value in the array that has the index of length divided by 2. Then I find the next one, which has an index of length divided by 2 plus 1. So yeah, that's how you do a median. I've created my model, and I'm very happy with myself. And I'm going to test for it, of course. And here I have another test case class, and I have a test median function, and I'm giving it a model, which is a portfolio, and then a list of stock subscriptions. And here you can see another function of hypothesis, which is you can specify values. So, okay, in the previous one, we found a test that would fail when a certain value was 0. And if you're really certain, it would also actually have failed with a negative number, because then you're going backwards in time. If you're really certain that you have controlled for this elsewhere, and no one is ever going to type in a negative number or 0 on your test, you can actually parameterize the values that you're giving the test with hypothesis. Which I'm sort of in two minds about. On the one hand, I think if you parameterize too much, you run the risk of just sort of falling into your own blind spots, really. You think, oh, well, obviously, I will never pass a 0 or negative value to this method. And so you clear that out of the way. But in fact, in your code, it turns out to be quite possible, just because of the way other methods work. And then I feel like you're missing out on a lot of what hypothesis can do for you. On the other hand, if I really only know, I only need to test for values in a very short range, and I ask hypothesis to run 100 examples over the range of, say, if you're talking about integers, negative to plus infinity, then it's really going to be wasting a lot of time. It's not going to be testing for important things. So this is a deal you have to kind of make with yourself, you know. How much does it bother you that you are restricting this versus how much does it bother you that you could potentially waste time on not useful values? So in this test, I'm setting it up so I can just check the maths. It's all very simple. And I want to say, give me a list of stock subscriptions where the value is in between 1 and 100. And then I'm just going to take my portfolio, add the subscriptions into the portfolio, and assert that the median value of the portfolio is between 0 and 101, which it always should be, right? That's, so yeah, quite a simple test. I run it with PyTest, and I get a really interesting error. Index error, list index out of range. I was not expecting this. And looking down at the falsifying example, it tells me this fails when I have a portfolio which has 2 subscriptions. And of course, if you look in the maths, which is just here, I look first for the thing in the sorted list that has the index of length divided by 2, so index of 1. And then I look for the value which has the index of length over 2 plus 1, which would be index 2, and suddenly I realize that Python indexes start with 0. I have possibly been writing too much in another language where they don't. There are some. It's horribly confusing. So it's a slightly subtler bug. And you can possibly, I'm not sure if you can see the bottom of my slides, but it actually tells me, again, the falsifying example is a portfolio with 2 subscriptions, and each of them just has a value of 0 and a symbol of 0, because that's the simplest it could make it. Okay, so that's how I would use hypothesis, both in a simple example and in an actual project. I'll just quickly go into some additional features that hypothesis has. As I said, there's a Django integration. You can generate strategies for your own Django models. If you're using validators in setting up your models, then the examples will all obey the pass in validating values. And you can also, I actually didn't show you this in the example, but you can fake generating child models. So I actually could have said, this is a portfolio, and the portfolio has child subscription models, and yeah, it would have come up with that in the same way. There's a bunch of other extras, including some for time zone aware date times, and some other things. There's especially, if you're using Python for science or data science, there are extras for NumPy and for pandas. The NumPy strategy, I've just put arrays there, but if you specify the content and the shape and the d-types that you want it to generate, it will just generate arbitrary arrays with those. And in the pandas extra, it has strategies for generating pandas indexes, pandas series, and pandas data frames. So yeah, that's exactly what you would want to just kind of go in there and have it work off the bat. And then finally, I've not got a lot of detail on this because it's a bit more complicated to explain in a sort of intro talk. You can also use hypothesis for rules-based stateful testing. And the 5-minute explanation of this is, previously you've been defining your tests more or less by hand because of your knowledge about your own code. And you've asked hypothesis to generate input. With rule-based stateful testing, it's actually more like you give hypothesis a series of operations that it can do. So for example, sort of classic would be you're testing database code and you want to be able to insert into the database, update values in the database, delete from the database, and so on. So you tell hypothesis all of these things it can do, and it generates sequences of those operations, looking for ones that cause failures. So if I add, and then I delete, and then I get, and then I delete again, can I coax your code to get into a failing state? And yeah, this sounds really complicated. Maybe it doesn't sound complicated. When you start reading about it, it feels complicated, to me at least. But actually, it's remarkably powerful, and it's really worth looking into. If you have code that depends on states, or if you find it interesting, really. I thought really hard about the summary for this slide, because I always find that the most difficult bit. And honestly, really, I only have one takeaway from this talk, which is please use hypothesis. It will think around you. It will test over ranges that you, as developer, have probably just completely got used to ignoring. I know that one problem I have with testing code, and I've seen a lot of people do this as well, is that I know exactly what doesn't work. So I just don't do that. And then when I give my program to a coworker or to a friend, I watch them sort of, going for this button or typing in this operation, and I just think, no, why would you do that? You know it crashed. So yeah, it's probably a lot cheaper than asking your friends to fuzz test all of your code, or your coworkers, to just use hypothesis. And yeah, take advantage of David spending all of this much time on it. And that's it. Thanks very much.
Okay, thank you. It was a really nice talk. So let's get to questions. So, do you have any tips on how to create properties for functions that modify global state, e.g. insert data to database?
Okay, so yeah, I guess one thing I would say is if this is what you want to test, have a go at looking into the rule-based stateful testing that I talked about at the end. On the other hand, if you, I know that for the Django Extra, which is sort of the specialized bit of hypothesis that I've used the most myself, as well as a test case model, there's a transactional test case model, which is designed for exactly this kind of testing, and that just makes sure that everything is transactional over the course of each example, so rather than over the course of the whole test, which is the default for PyTest. So yeah, I can do update models and so on with 100 different example inputs, and the test cases will be independent from one another.
Okay, thank you. What's the performance of hypothesis library like? Isn't it? Oh, okay. Isn't the default value of 100 values too much?
Actually, it's not a problem. I mean, a lot of the time, I find it takes less than 100 examples to find a bug if there's one there to find. Performance is something that I know David and the other hypothesis developers have worked on a lot. And actually, I don't find 100 values is a real problem. If you're, the transactional test case that I mentioned actually can be a bit of a performance bottleneck, obviously because it's sort of resetting the global state every example. But yeah, I think 100 values is fine. Don't know if that was a good answer.
Yeah, well, it is an answer, so good. For the anonymous. Okay, Heike, can you specify the structure of the pandas data frame in hypothesis?
Yes, I believe you can. I don't do a lot of pandas work, and I haven't actually used that part of hypothesis. But yes, I think that's absolutely possible with the extra.
Okay, thank you. The next question, can you use it to test complex systems? For example, handshake communication.
I believe you probably could, and if not, I believe you could modify it to do that. But I don't know from personal experience, sorry.
No problem. And the last question from the Slido, do you combine standard using unit testing together with hypothesis?
I'm not really sure how you mean combine. I mean, I use hypothesis in my unit tests, yes. But the tests that I write with hypothesis are not example-based. I just write the properties that I expect to hold true. And I find this makes the process of writing unit tests a lot quicker and easier because I don't have to try and think of a failing case, a passing case, an edge case. A hypothesis just finds them.
Awesome. Thank you.